In this video, I focus on understanding user interests and recommending posts. I wanted to track how much time a user spends reading or viewing a post to understand their interests. Using the existing polling system for posts, I increment a view count each time a user stays on a post. This way, longer engagement increases the weight of that post. I also explored text embeddings for the post content. After comparing OpenAI and Google, I chose Google GenAI and tested it with a simple Python script. Next, I installed pgvector in Postgres to store embeddings and index them for similarity searches. I used an IVF flat index. I initially considered using a weighted average of post views to determine user interest, but that would flatten multiple interests. Instead, I built a user cluster model where each cluster stores a centroid embedding representing a user's interest in a topic. When a user interacts with a post, the system compares the post's embedding to the centroids of the user's existing clusters. If the post is close enough to an existing cluster, it is added there, and the centroid is updated using incremental averaging. The system calculates the new centroid based on the existing average and the number of posts in the cluster without having to sum all embeddings from scratch. If the post is too far from all existing centroids, a new cluster is created to represent this new interest. Different interactions influence clusters differently. Sending a post to chat counts the most, followed by saving a post, commenting, replying, liking a post, liking a comment, and finally just viewing a post. These weights are configured in Django settings and determine how strongly each action affects the user's interest clusters. Since we have the count variable in the user's interest, we know how many posts are there and how strong the interest is for that cluster, so it can identify a user's top interests. Previously recommended posts are stored in the database and ordered lower rather than excluded completely, so users still see older posts once new ones run out. I also added a cosine similarity threshold, so only posts close enough to the user's interests are recommended. I created a signal that generates an embedding whenever a new post is created. Each interaction, likes, comments, replies, saves, sending posts to a chat, and post views also triggers signals that update the user's cluster with the configured weight. For post views, I only consider them for recommendations if a user has spent more than 10 seconds on a post. This prevents short accidental views from skewing interest. To make interests traceable, each cluster tracks its member posts